Welcome to the deep dive.
Mhm.
I'm so glad you're here with us today because we're going to completely redefine how you think about your daily energy levels.
Yeah, thanks for having me. It's a huge topic.
It really is. You already know that mitochondria dictate your energy. You don't need us to repeat the basic high school biology, the powerhouse of the cell stuff.
Right, we're moving way past that textbook definition.
Exactly, because the latest quantum biology research we've pulled together for this goes way beyond the standard metabolic models. Think about this for a second. What if that sluggish, brain foggy fatigue you feel at like 2 p.m. isn't just about a bad night of sleep?
Or just needing another cup of coffee.
Right. What if it's about the microscopic engines inside every single cell in your body functioning less like engines and more like, well, like quantum batteries?
I love that analogy. Or if you look at the Ayurvedic tradition, they actually call it Agni, right? The inner fire.
Yes, the inner fire. The sources we're looking at today really position these tiny structures as the literal physical bridge between the physical food you eat and the energetic life force you actually feel.
Because when we talk about energy in this context, we aren't just talking about, calories on a nutrition label. We are talking about adenosine triphosphate.
ATP.
Exactly, ATP, and the electrical gradients that these mitochondria manage. I mean, they're incredibly dynamic networks. They're constantly sensing your environment, deciding in real time whether your cells should be in a state of robust health
But
or...
like a defensive lockdown state.
Right, and the literature reveals that we have an incredible amount of behavioral control over that sensing process.
Which brings us to our mission for this deep dive. We've come through a massive stack of research today, ranging from bioenergetics and quantum biology to the physical effects of sound vibrations and temperature stress.
A lot of ground to cover.
It is, but our goal for you today is to extract the absolute best science-backed steps from all of this to build a simple, step-by-step daily routine.
Actionable stuff.
Completely. We want to lay out the specific do's and don'ts to help you optimize your mitochondrial function, boost that ATP production, and clear out the old malfunctioning zombie cells that are just draining your energy. It really is a complete system overhaul. Okay, let's untack this, starting right when you wake up, because the research makes it super clear that mastering the morning is non-negotiable.
Specifically when it comes to light exposure.
Yeah, that blew my mind.
Right. Mitochondria operate on a strict circadian rhythm, much like the suprachiasmatic nucleus in your brain.
The master clock.
Exactly. And the primary signal setting that cellular clock is light. But a detail that often gets overlooked is that mitochondria are actually photoreceptive themselves.
Meaning they literally sense light directly.
Yes, they contain a specific enzyme called cytochrome C oxidase. And this enzyme doesn't just help process food, it directly absorbs specific wavelengths of light.
Especially in the red and near-infrared spectrum, according to the sources.
You got it. When it absorbs those photons, it physically accelerates the electron transport chain, which just ramps up the production of ATP.
So I was reading through these photobiomodulation studies, and it seems like a massive do is getting full-spectrum sunlight within the first 30 minutes of waking up.
It's one of the most powerful things you could do.
And the sources mentioned this triggers the release of something called mitochondrial melatonin, which confused me at first because I always thought of melatonin as just the hormone that makes you sleepy at night.
It's a really common misconception.
So how does a sleep hormone fit into a morning routine aimed at waking you up?
Well, it is a critical distinction. The melatonin released by your pineal gland at night is indeed for sleep. It goes into the blood. But mitochondrial melatonin is entirely different.
It doesn't make you drowsy.
Not at all. It doesn't enter the bloodstream. It stays localized inside the cell. Its primary role is to act as a localized, heavy-duty antioxidant.
Oh, wow.
Yeah, because as your mitochondria produce energy throughout the day, they naturally generate exhaust, free radicals. So the morning sunlight triggers the mitochondria to bathe themselves in melatonin, repairing that cellular damage from the inside out before the oxidative stress can even accumulate.
That is wild.
Yeah.
And if you live somewhere gloomy or it's winter and the sun just isn't available,
Then you can use red or near-infrared light therapy panels, specifically hitting that 600 nanometer to 900 nanometer range. That specific wavelength can physically bypass the skin and energize that deep tissue directly.
okay, but the reverse of this light equation is just as vital. So here's a massive don't. Don't reach for your phone immediately when you open your eyes.
Definitely not.
Because the artificial blue light from a screen essentially confuses that delicate mitochondrial clock we just talked about.
It creates a biological mismatch. Your cells are expecting the gradual red-heavy spectrum of the sunrise to gently start the engines.
Like-
Blasting them with isolated blue light from your phone is like redlining a cold car engine. It sends a jarring environmental signal that can induce oxidative stress before you've even gotten out of bed.
So put the phone down, get in the sun, and while you were standing in that morning light, the sources suggest adding a practice that honestly sounded a little bizarre to me at first.
The humming.
Yes, a 5-minute hum. Why on earth is vocal resonance showing up in bioenergetics research?
What's fascinating here is, well, there's this landmark study from the Karolinska Institute. The researchers demonstrated that simple humming, which is very similar to the Brahmari or bee breath used in ancient yogic traditions, increases nasal nitric oxide output by a staggering 15 to 20-fold
15 to 20 times more.
compared to normal quiet exhalation. Yes. And nitric oxide, or NO, is a vasodilator. It relaxes the inner muscles of your blood vessels, causing them to widen.
So it opens up the highways.
Exactly.
Yeah.
This massive increase ensures your blood flow is optimized, delivering a huge payload of oxygen to your cells.
And oxygen is the absolute key here, right? Because in the mitochondrial energy chain, oxygen acts as the final electron acceptor.
That is the core mechanism. To produce ATP, mitochondria pass electrons down a chain of proteins.
Mm-hmm.
But those electrons have to go somewhere at the end of the line.
Someone has to catch them.
Right, and oxygen sits at the very end of that chain to catch those electrons. If you don't have enough oxygen being delivered efficiently to the cell, the whole assembly line backs up.
Energy production stalls.
And you get a buildup of those damaging free radicals. So by humming for 5 minutes, you're using physical sound waves to mechanically open your blood vessels.
You're making sure the final catcher in the assembly line is ready and waiting. You're literally using sound to flood your cellular engines with oxygen.
It's an incredible zero-cost tool.
So the morning is sorted with light and oxygen, but by the time noon rolls around, that initial charge starts to wear off. How should we be fueling our bodies to keep this momentum going?
Especially when it comes to clearing out the cellular junk, which is crucial.
Yes, the research really emphasizes a process called mitophagy.
Mitophagy is the microscopic equivalent of taking out the trash. Just like any engine, mitochondria experience mechanical wear and tear.
And when they become damaged, they mutate into what biologists call zombie mitochondria, right?
Yeah, zombie cells. They refuse to die, but they stop producing meaningful amounts of ATP. Instead, they just siphon off your body's resources and spit out highly reactive, toxic free radicals.
The absolute worst guess. So how do we force the body to dismantle and recycle them?
Through the strategic scarcity of fasting.
Now, time-restricted feeding is everywhere these days. But the literature we reviewed stresses that closing your eating window isn't just a one-size-fits-all prescription. There are very distinct gender-specific rules.
Oh, absolutely. The biological responses to fasting are fundamentally different for men and women.
I was really surprised by how divergent the protocols need to be.
Well, for men, the male mitochondrial network generally tolerates prolonged scarcity quite well. So aiming for a 16 to 18-hour fasting window aggressively stimulates that mitophagy cleanup process.
Men's bodies use that deprivation to seek out and destroy the weakest cells.
Right. But to support the higher metabolic demands and testosterone turnover once they do eat, men require about 30% more healthy fats and zinc in their diet. Foods like pumpkin seeds and oysters are excellent for this.
But the research actually cautions women against those longer fasting windows. It seems women's mitochondria are highly sensitive to famine signals.
Because the female biology is intricately tied to reproduction. Prolonged fasting sends a signal to the cellular network that the environment is hostile.
So the body thinks it's starving.
It interprets it as a state of famine, which cascades into hormonal downregulation to conserve energy.
So what's the dough for women here?
For women, limiting fast to a gentler 12 to 14-hour window provides the benefits of mitophagy without triggering the cellular panic button.
And nutritionally, the sources say women require significantly more heme iron, which is highly bioavailable in foods like liver and red meat.
Yes, and that iron isn't just for preventing anemia. It plays a major structural role in the mitochondria.
It's an architectural component, isn't it?
Critical.
Yeah.
Inside the electron transport chain we mentioned earlier, there are these structures called iron-sulfur clusters. They are literally the physical stepping stones that the electrons bounce across to generate energy.
So without sufficient heme iron, you can't build those clusters, and energy production just bottlenecks.
Exactly.
That distinction alone could save a lot of people from accidentally crashing their energy levels through overfasting.
This is so common.
Now, when you actually break that fast, the sources provide a fantastic framework called the 3-cup rule.
I love this rule.
It calls for 3 cups of leafy greens, 3 cups of sulfur-rich cruciferous vegetables like broccoli and Brussels sprouts, and 3 cups of deeply colored vegetables.
It sounds like a massive volume of food.
It does. Why is
Mhm.
the research pushing so hard for these specific categories?
It comes down to the raw materials your cells need for defense. The sulfur-rich vegetables are particularly vital because your body uses that dietary sulfur to synthesize glutathione.
The master antioxidant?
Yes. Unlike other antioxidants you might just ingest, glutathione sits directly inside the mitochondria. It physically shields the mitochondrial DNA from being shredded by free radicals,
And the colored vegetables.
packed with polyphenols.
Yeah.
They weave themselves into the outer membrane of the mitochondria, acting as an additional protective shield against environmental toxins.
Okay, so while you're getting those 9 cups of vegetables in, the research highlights 2 massive powerhouse nutrients you should be focusing on: CoQ10 and PQQ.
Both are essential.
CoQ10 acts as the spark plug for ATP production, right? You find it in high concentrations in foods like beef heart and sardines.
But there's a pro tip from the dietary research here. CoQ10 is highly fat-soluble.
Ah, so if you take it as a supplement or eat it, you must pair it with a healthy fat.
Like avocado or olive oil. Otherwise, it just passes right through your system unabsorbed.
A total waste. And then there's PQQ, found in foods like kiwi and parsley. I found PQQ fascinating because it doesn't just support existing mitochondria, it triggers biogenesis.
And biogenesis is the holy grail of bioenergetics. It's the literal creation of entirely new mitochondria.
And if you want to push that biogenesis even further, the sources brought up a really compelling traditional herbal extract called danshin.
The pharmacological research on danshin is incredible. It shows the extract significantly increases the expression of a protein called PGC1 alpha.
Let's decode that for a second. What exactly is PGC1 alpha doing in the body?
Think of PGC1 alpha as the master switch in your DNA that tells the body it is time to build more engines.
So when danshin flips that switch, your cells start physically multiplying their mitochondrial count.
Yes. The studies also show danshin increases UCP1, or uncoupling protein 1.
Uncoupling. That sounds bad, but it isn't, right?
Well, UCP1 is a protein that basically opens the windows in a hot room to let the heat out, instead of using that energy to do cellular work. In specific tissues, like brown fat, this deliberate heat generation is incredibly beneficial,
Because it burns massive amounts of calories to keep you warm.
which protected the subjects in the studies against obesity and fatty liver disease.
That is a brilliant transition, actually, because uncoupling is a double-edged sword.
It really is.
While it's great in brown fat for burning calories, you don't want generalized uncoupling happening everywhere else.
Right, which brings us to a major don't.
The dietary research explicitly warns against consuming high amounts of fructose in processed seed oils for this very reason. These highly processed foods cause pathological uncoupling.
It's disastrous for the cells.
Basically, your mitochondria try to turn that junk food into usable cellular work, but the machinery gets jammed and the energy gets completely wasted as friction and heat instead of forward motion.
It's the cellular equivalent of revving your car engine while the transmission is in neutral. You are burning fuel, generating immense oxidative exhaust, but going absolutely nowhere.
And speaking of toxins, the sources also highlight avoiding conventionally grown crops on the dirty dozen list.
The pesticide residues.
Yeah, on those specific fruits and vegetables, they are notorious for penetrating the cell membrane and directly inhibiting the mitochondrial enzymes we've been talking about.
They literally poison the engine.
Okay, so we've navigated the midday fuel. Let's look at the afternoon. The sources lean heavily into movement and temperature, introducing a biological concept called hormesis.
I love the analogy of treating your mitochondria like a garden.
Right, you can't just yell at a plant and force it to grow. You have to apply the right beneficial stressors. A little bit of harsh wind, the right amount of intense sun to prompt natural, resilient growth.
Hormesis is exactly that, a deliberate, beneficial stress that forces your body to upgrade its hardware.
Because the body is ruthlessly efficient, isn't it?
Oh, completely. It will not expend the energy to build new infrastructure unless you give it a compelling reason to do so. And the most effective way to apply that hormetic stress is through targeted exercise.
The literature advocates for a specific DO here, a combination of Zone 2 cardio and HIIT, high-intensity interval training.
They trigger completely different mitochondrial adaptations.
I always thought steady-state cardio was enough for baseline health. Why do we need to mix the conversational pace of Zone 2 with the brutal maximum effort intervals of HIIT?
Well, spending long durations in Zone 2, where you're working but can still hold a conversation, trains your existing mitochondria to become incredibly efficient at utilizing fat for fuel.
So it builds a wide, highly efficient base.
Exactly. But HIAT creates a sudden massive deficit in ATP. That short burst of maximum effort temporarily panics the cell.
The cell realizes its current infrastructure just isn't powerful enough to survive that kind of demand again.
So it flips that PGC1 alpha switch we talked about,
Hmm.
forcing the biogenesis of new mitochondria.
You're expanding the capacity of the engines you have and then forcing the body to build more of them.
And you can stack that mechanical stress with thermal stress,
Taking a cold plunge.
or even just a 3-minute cold shower. It activates that brown adipose tissue we touched on earlier.
Brown fat. That unique type of tissue located around the collarbones and spine that is densely packed with mitochondria, specifically designed to burn calories just to generate heat.
If we connect this to the bigger picture, there is a profound synergy between the cold and the exercise. We reviewed a fascinating study looking at mice to understand this interaction.
Oh, the swimming mice study.
Yes. They had one group of mice swimming in cold water, about 24 degrees Celsius, and another group swimming in neutral, lukewarm water, around 34 degrees Celsius. The researchers were looking at inguinal white adipose tissue.
Just to clarify for everyone, inguinal white adipose tissue, that's the stubborn subcutaneous belly and groin fat that doesn't normally burn energy, right?
Correct. It's the lazy fat that just stores energy. The researchers wanted to see if cold could turn that white fat into energy-burning brown fat.
And what did they find?
They found that cold exposure alone was not enough to trigger that transformation. Exercise was the necessary prerequisite.
Wow.
It was the combination of the physical exertion and the thermal drop that maximized the expression of PGC1 alpha and another protein called NRF1.
NRF1?
Think of NRF1 as the cellular architect that drafts the actual blueprints for the new mitochondria.
So the synergy of cold and movement literally taught the lazy white fat to act like high-performance brown fat.
Exactly.
That completely flips the script on how we think about recovery.
Yeah.
I mean, sitting completely motionless in an ice bath has benefits, but actually moving while cold or getting cold immediately after the mechanical stress of a workout is what unlocks that deep cellular upgrade.
You can't just eat perfectly and expect your mitochondria to multiply. You have to actively stress the system.
The don't here is relying on maintenance alone. But once that afternoon work is done, the strategy has to shift entirely. You have to signal to those cells that the work is over and it's time to repair.
Which brings us to the evening wind down.
Yes, which is all about coherence, your acoustic environment, and the vagus nerve.
We established earlier that mitochondria are constantly sensing their environment.
Right.
When you are chronically stressed, whether that's physical overtraining or psychological anxiety, your mitochondria pick up on those chemical signals.
They stop producing energy and go into a defensive posture.
A state the literature calls the cell danger response, or CDR.
The CDR sounds like a strict evolutionary survival mechanism. If a cell thinks a virus is attacking or you're running from a predator, it just shuts down the power grid to wall itself off.
Exactly. But to get out of the CDR and back into repair mode, you have to convince your biology that you are safe.
And the superhighway for delivering that safety signal is the vagus nerve.
The vagus nerve wanders from your brainstem down through your heart, lungs, and digestive tract. And the sources cited a phenomenal study on vagus nerve stimulation, or VNS.
What did it show?
They found that applying stimulation to the vagus nerve significantly improved mitochondrial dysfunction, even in extreme, life-threatening cases like post-cardiac arrest syndrome in animal models.
It literally pulled the cells out of the danger response.
Yes. And you don't need an implanted medical device to achieve this. You can naturally tone your vagus nerve using prosodic, warm, melodic speech.
Because your vocal cords are innervated by the vagus nerve. So the physical vibration of speaking warmly sends a mechanical safety signal down the nerve pathway.
Which leads to a huge don't for the evening.
Right. Engaging in a high-stress, sharp argument right before bed isn't just bad for your relationship. It is demonstrably toxic for your cells.
Argumentative shouting spikes cortisol.
And chronic cortisol causes the mitochondrial membranes to leak, which directly damages your mitochondrial DNA.
You are literally frying your quantum batteries with your own stress hormones. And along with how you speak, what you are passively listening to dictates your cellular reality. The environmental cues in your home are constantly being processed at a microscopic level.
This leads to one of the most incredible studies in the entire stack.
Oh, the cell study.
Yes. Researchers took human kidney cells in a lab and exposed them to different types of music and spoken words. They weren't attached to a brain or ears, just isolated cells in a petri dish.
It's amazing.
When they played classical music or traditional Chinese five-element music, the five-element music actually increased mitochondrial ATP synthesis by 17%.
It also drastically reduced reactive oxygen species, the free radicals that age us.
Even just exposing the petri dishes to words with positive, calming meanings increased ATP levels and sped up the physical repair of the cells after they were subjected to stress.
It is a profound demonstration of mechanotransduction.
Yeah.
The reality that physical waves of sound can alter the structural and chemical behavior of a cell.
And the researchers looked at the inverse as well. If you want cellular rest, heavy metal music had the exact opposite effect.
The study showed that heavy metal negatively affected cell viability, increased those damaging reactive oxygen species, and actually decreased a vital enzyme called SOD.
SOD being superoxide dismutase, right. The enzyme that acts as your cell's built-in fire extinguisher for oxidative stress.
Exactly. The aggressive sound waves suppress the cell's ability to put out its own biochemical fires.
So, Dito throw on some classical or five-element music, keep the conversation warm and melodic, and practice heart-focused breathing.
Breathing slowly while focusing your attention on your chest creates what researchers call psychophysiological coherence.
It smooths out your heart rate variability, reduces the overall metabolic cost of just being alive, and provides a calm, steady sea for your mitochondria to do their repair work overnight.
It's the perfect state for recovery.
So what does this all mean? Let's bring this routine together into a single blueprint. The ultimate science-backed day for your microscopic engines looks like this. You wake up, bypass the phone, get out into the morning sunlight, and spend 5 minutes humming to spike your nitric oxide and open your blood vessels.
Then, you move into your day practicing targeted, gender-appropriate fasting.
Right. You break that fast with a nutrient-dense diet, leveraging the 3-cup rule for glutathione production, loading up on CoQ10 with healthy fats, PQQ, and perhaps danshin extract.
In the afternoon, you hit your body with hormetic stress, combining the fat-burning base of Zone 2 cardio, the biogenesis-triggering burst of HIT, and some cold exposure to force the blueprinting of new batteries.
And finally, you spend your evening pulling your cells out of the danger response through vagal toning. Warm conversations, coherent breathing, a curated acoustic environment, and strict blue light hygiene.
This raises an important question. What is the ultimate end goal of all this stewardship?
It's a great question.
We've talked extensively about ATP and chemical energy, but the source has left us with one final, truly mind-bending concept from the bleeding edge of quantum biology: biophotons.
Biophotons.
The research into quantum coherence in biological systems reveals that our mitochondria don't just produce chemical energy, they actually emit ultra-weak light signals, or biophotons.
They emit light.
Yes. They use these microscopic pulses of light to communicate with one another across the cellular network. When we are highly stressed, sick, inflamed, or constantly in the cell danger response, the light emission measured from our cells is erratic and chaotic.
But when we follow a routine of cellular stewardship,
When we cultivate that physiological coherence through our daily actions, the light emitted by our cells becomes highly structured, rhythmic, and harmonious.
it makes you wonder, if our cells are constantly communicating via delicate pulses of light, how do the artificial light environments we live in, or even the chaotic, energetic states of the people we interact with, disrupt our own internal cellular symphony?
Are we unintentionally scrambling our own biological communication every time we walk into a fluorescent-lit office?
Or doom scroll before bed? It's something to think about the next time you feel that 2 p.m. slump. Thank you so much for joining us on this deep dive. I highly encourage you to start with just one thing today. Try that 5-minute hum or plan out your fasting window. Your quantum batteries will thank you. Catch you next time.